All right, let's look at the meaning of divergence. All right, so let's do a two-dimensional case so it's easier to draw a picture. So we have a vector v function v, and this represents the flow of some sort of fluid. All right, so let's say you have a point x1 comma y1. The flow is basically outward, so this is a source of this flow. And the other point is the x2 comma y2, where all the flow is into that point, so this is going to be the sink of the flow. Right. When you look at the divergence of this function of this flow at say x1 comma y1, then the divergence is going to turn out to be positive. So this guy is going to turn out to be positive. So if you have a positive divergence, then flow is going outward. So that's why it's called divergence. Flow is diverging from that point. And when you have a sink where the flow is going into that point, then the divergence of that flow is going to turn out to be negative, right? Let's try to make sense out of that. So let's just look at kind of an extreme case. So when you do so V is going to have two components, V1 and a V2. Since we're doing a two-dimensional space, we can do a three-dimensional flow too. All right, and let's say, so if you take the divergence of this V function, it's going to be partial of V1 with respect to x plus partial of V2 with respect to y. So that's the divergence. Let's just say, both of these guys turn out to be positive. So let's say this is positive and that is positive. All right. So V1 is the x direction of this flow, and in the x direction the flow is increasing. So I'm trying my best to visualize that behavior. So I would probably draw something like this. So flow is going to be smaller and getting larger and larger and larger and larger. So that's kind of what's going on in the x direction. And since we're assuming that in the y direction the partial derivative is also positive, so which means that the other direction the flow is, so here you go, and getting larger and larger and larger and larger, right? Then if you look at this point, say like a point right here, right, you notice that the flow going into that point is going to be less than the flow going out of that point, so which has a tendency of diverging away from that point. And the same way in the y direction, and if you look at the flow going into that point, it's going to be less than the flow going out, right? So you can see that the positive divergence indicates the overall flow outward. So that's why divergence is going to be positive when you have a source. The flow is going out of that point, right? And you can see the other way around. If the divergence turns out to be negative, flow going into that point is going to be more than flow going out of that point. So that's why the overall flow is going into that point. So that way this point is going to be a sink, which is represented by which is indicated by the divergence being negative, right? That's it. I hope that this was clear.